Alright guys, so this is chapter 55 and this is part 1. And the whole purpose to chapter 55 is to take a look at your ecosystem. So over the last couple of chapters, we've kind of been zooming out and looking at bigger and bigger pictures. So the first part of chapter 55 really goes through your ecosystems, and now we're taking a look at those interactions between both the abiotic materials, so your water, your sunlight, your nutrients, and how that's going to affect the living or the biotic portion of our ecosystems. And then the last part of chapter 55 just goes into a little bit about restoration ecology, human disturbance, and sort of leading us into the last chapter that you'll take a look at, which is chapter 56. So if we kind of remember our definition for an ecosystem, we're talking about all of the living organisms, so all the community of our ecosystems also then includes the abiotic factors. So this level of ecology really kind of focuses on the energy that's coming in, how it flows through the system, where it exits, and then also how does that sort of compare to the cycling of chemical nutrients within the ecosystems. So if we talk about energy flow, we really need to take a look at how does energy come in, how does it get transferred from one portion of our ecosystem to another, and then how does it exit, and what are the processes that are going on to change energy from one form to the other, and how does that then connect to the nutrients that are passing through our food chain. So those nutrients and that energy are all going to start at the bottom of your food chain, your primary producers, your autotrophs. All right, and they're going to be able to fix those nutrients and fix that energy so that it can then be passed to our primary consumers, which are your herbivores. All right, and then up to your secondary consumers, tertiary consumers, so on and so forth. And then ultimately, how does that, once it gets to the top of our food chain at our top carnivores, get redistributed back into the abiotic side of our ecosystems with our decomposers? All right. What we need to keep in mind, though, as we're looking at all of these cycles and transfers, is that we're still bound by the laws of physics, the laws of chemistry, particularly with regards to the flow of energy. So for those of you who haven't seen this or just don't remember, all right, your laws of thermodynamics are really sort of the physics portion to this. And the two laws that we're going to focus on here, and these will come back later in the school year, are that first law just saying that we can't create or destroy energy. All right, so the amount of energy that you have in your ecosystem is going to be the same going in as coming out. And so what we're really looking at is that transfer that's happening. Okay, so I've got X amount of energy coming into my ecosystem via my producers. That's going to get transferred, gets transformed into different types of energy as it goes through the food chain. But I'm not creating new energy and I'm not destroying it. Okay, so that energy comes in as that solar radiation. It's conserved within our ecosystem, with the small exception that those organisms are going to lose some of that usable energy as heat. All right, so we're not really destroying energy, it's just changing into a form that I can't use as an organism anymore. Okay, and that's where that heat comes in. Your second law of thermodynamics takes a look at the exchanges that happen, or the transfers of energy that happen from one form to the next. And all the second law is stating is that every time I change energy from one level to the next, all right, I'm going to increase this idea of entropy or disorder within my universe. So kind of think of it as if you just left your room, and never touched it, never put any energy into it, if you will, it kind of ends up a big mess, right? But in order to sort of keep the order, if you will, you've got to put energy in. So in your ecosystems, those energy conversions aren't completely efficient. All right, remember that 10% idea is what we get transferred because the organisms at each trophic level need the energy in order to do their own metabolic processes, and some of that energy not only gets used up there, but then also gets lost as heat. Okay, so we're only transferring about 10% every time we go up at a trophic level, and that's really what that's coming down to. We also have to talk about the law of conservation of mass, and this is sort of more the chemistry side of things, more the nutrient cycles. All right, so we can't create or destroy energy, but we can't create or destroy matter either. So our nutrient cycles are going to constantly recycle those chemical elements within our ecosystem. So we're very much limited to what's already there in place and how do we change its form so that organisms can use it, but then it's got to get recycled back to the abiotic side of those cycles so that it can get reused by the next generation, if you will. Okay. Now, these laws are sort of described in closed systems. What does that mean? That means we're not having an influx, outflux of materials, of energy. Sort of think of it as sticking it in a bottle. You can't get things out in or out unless you open the bottle. All right. But our ecosystems are that open bottle. There's constantly shifts from other places that are bringing in extra energy, bringing in extra mass, and also taking it away. All right, so globally speaking, we're not creating or destroying energy, we're not creating or destroying mass, but within given ecosystems, we kind of can. All right, because it can get transferred out somewhere else, or we can bring new stuff in. Think of it like the farmers on the fields. All right, if they don't have enough nutrients in the soil, we're bringing outside sources to add extra nutrients via the fertilizers and that sort of thing to ensure that we have what we need. Okay, so that's the idea there. And if you take a look kind of just at a big picture, all right, you can see if you follow the red versus the blue arrows that your energy is really going to flow in one direction. Okay. So it's going to go from the sun. We're going to lose a little office heat every level. All right, but that energy is going to get transferred or is going to flow from primary producers to primary consumers, secondary, tertiary consumers, down to the detritus, which goes down into our microorganisms and our detritivores and gets kind of cycled back a little bit. But the chemical cycling is really a cyclical process. All right, so we're constantly moving those chemicals from different levels and it all gets cycled back at the end. But the energy's coming in one direction and we're going to only be able to really move in one direction. Okay, so that's the big difference there. Sort of, as the key says, the energy's going to flow in one direction. Your chemicals are going to cycle. All right, and so those are going to be the ones we are capable of kind of recycling and reusing. The energy, once it's there, it's going to move up the food chain and kind of get lost at the other end. Okay.